aldehydes or ketones are treated with aqueous sodium hydroxide solution, dilute sodium hydroxide solution or 50% solution of sodium hydroxide. The reactions follow to different pathway because aldehydes or ketones, there are two types of aldehyde and ketones. One is where no alpha hydrogen atoms are present, and the other type of aldehyde or ketone where alpha hydrogen atoms are present. Now first of all, what is alpha hydrogen? In both aldehyde and ketone, this group is common and it is carbonyl group. Now when carbonyl group, the other bond is made with hydrogen atom, this functional group is called an aldehyde group. And if in both hands of the carbon some alkyl groups are present like CH3 and here also CH3 or any alkyl groups, then this is called a ketone. So aldehyde and ketone both contains C double bond group. If only one hydrogen atom is there and the other is an alkyl group, then this is an aldehyde. This compound is an aldehyde. And if and where both the groups are in both hands of the carbon is alkyl groups, then it is ketone. Now aldehyde may be of two types like HC double bond OH, this one is also an aldehyde, and CH3 C double bond OH, this is also an aldehyde. This is called formaldehyde, and this one is acetaldehyde. Now here the carbon which is directly attached to carbonyl carbon is called alpha carbon. The next, if there is another carbon atoms present, then that will be beta carbon and then gamma carbon. So the carbon which is directly bonded to a carbonyl carbon is called alpha carbon, and all the hydrogen atoms present in this carbon are called alpha hydrogen. So this aldehyde molecule contains alpha hydrogen, and this molecule of aldehyde doesn't contain any alpha hydrogen as there is no alpha carbon is present there. Now if we treat both the aldehydes by sodium hydroxide solution, then what happens? Sodium hydroxide being a base dissociates to form OH minus ion, and here also we give sodium hydroxide, and here also OH minus ions are present. Now OH minus ion, at first OH minus ion is a base, that is it has always the tendency to abstract a H plus ion and show its basic nature. If there is no acidic hydrogen atoms are present, if it has no chance to show its basic nature, then as it is carrying a negative charge, it will be acted as a nucleophile. As it is carrying a negative charge, it will be attracted towards a nucleophilic center, that is towards a positive center, and hence it will act as a nucleophile. Alpha hydrogen atoms, here 3 alpha hydrogen atoms are present. These alpha hydrogen atoms are acidic in nature. Why this is so? Because the carbonyl group, in both the cases, the carbonyl group, as oxygen is more electronegative than carbon, then the pi bonded electrons are shifted more towards the oxygen atom, making this oxygen partially negatively polarized and that carbon partially positively polarized. Now to reduce its positive charge, it will attract the bond pair electrons from the other bond which is with the carbon atom. Now it is a methyl group, and methyl group has plus I inductive effect, so it will also push the bond pair electrons towards carbon. So the both effect direct to the same side gives rise to some charge separation. So this carbon becomes electron deficient as it is pushing the bond pair electrons towards the carbon, and carbonyl carbon also pulling the bond pair electrons from this bond, that makes this carbon electron deficient, and this carbon, because it is electron deficient, it attracts the bond pair electrons towards itself. So this effect we can say it is a minus effect of carbon that is passing through this carbon to the hydrogen, and hydrogen becomes partially positively polarized, and that's why it can easily be removed as H plus ion, giving up its bond pair electrons over this carbon atom. So here OH minus ion is present, and here alpha hydrogen atoms are also present. So OH minus ion will show its basic nature instead of its nucleophilic nature. Okay, so if we add sodium hydroxide in an aldehyde or a ketone where some alpha hydrogen atoms are there, then OH minus ion will act as a base and will uptake a proton, that is uptake the alpha hydrogen and be removed as H2O. So here what is formed is a carbon ion. CH2 will have a negative charge, and then the remaining C double bond of H group remains same. Now what happens with this, where no alpha hydrogen atoms, that is no acidic hydrogen atoms are there, OH minus ion has to react as a nucleophile, and since carbon and between carbon and oxygen is more electronegative, the bond pair electrons are shifted more towards oxygen, giving rise of a charge separation, whereas carbon is having a partially positively charged and oxygen is partially negatively charged. So it is a nucleophilic center where a nucleophile can attack, and here a nucleophile is present which is OH minus, it is carrying a negative charge. So OH minus will attack to this nucleophilic center and will make a bond with the carbonyl carbon. As carbon has a covalency of 4, it cannot make a covalent bond greater than 4. So when a bond is formed between OH and carbon, that pi bond has to be broken and will be broken to oxygen atom, as oxygen atom will get a negative charge. So what is formed here, H bond C bond H, here it becomes a single bond, oxygen will have a negative charge and a bond is formed between carbon and OH. So this is the product when an aldehyde having no alpha hydrogen atoms is treated by aqueous sodium hydroxide solution, and that is the product where an aldehyde which is having alpha hydrogen is treated with aqueous sodium hydroxide solution. Next, after then what happens? Again another mole of HC double bond OH is involved in this reaction. Here a back bonding occurs, then carbon will make 5 bonds, which is not possible, so one bond has to be broken. If this bond breaks, then the starting material again produces, so that not happens. What happens exactly is this hydrogen removes as H minus ion by taking up its bond pair electrons. So H minus ion, hydrogen is carrying a negative charge, that hydride ion must be a nucleophile, and here a nucleophilic center is present. Here carbon is partially positively polarized and the oxygen is negatively polarized, so that H minus ion which is removed from here will attack to this carbonyl carbon. So two molecules are formed. Here we can see H bond C, here double bond O, then this OH, that is formic acid is formed, along with here 2 hydrogen atoms are present and another hydrogen atoms comes from this molecule, so CH3, and when hydrogen comes, that pi bond has to be broken, so CH3 then O, and with a negative charge, and that negative charge will be neutralized by the Na plus which is there in the aqueous solution. Okay, now if you acidify this solution with a dilute acid, then the final product is HCOOH, that is one molecule of acid and another molecule of alcohol, CH3OH. This reaction is known as Cannizaro reaction. So in Cannizaro reaction, when an aldehyde is oxidized, it forms acid, and when an aldehyde is reduced, it forms an alcohol. So here we can see that aldehyde forms both acid and alcohol. That is, here aldehyde becomes oxidized and reduced simultaneously. So this reaction, we can say this reaction as a disproportionation reaction, where the same molecule is getting oxidized and reduced. Now what happens with this? Now this carbon ion, it is fully a nucleophile. It is neither a base, so it will not will be looking for an acidic hydrogen, so it is purely a nucleophile. So when another molecule of acetaldehyde is given, then what happens? This negative charge attacks to this carbonyl carbon, which is a nucleophilic center, and as a result that pi bond breaks and oxygen gets a negative charge. So a bond is formed between this carbon, this alpha carbon, and this carbonyl carbon. So we write from this, we start right from this methyl group, so CH3, then C single bond O minus, and carbon has a hydrogen atom, and here a bond is formed between this carbonyl carbon and this alpha carbon. So here CH2, then single bond C, double bond OH. This is the form, this is the product formed, and if you acidify this by a dilute acid, then it will absorb H plus ion to have this molecule CH3 CHOH, then single bond CH2, then single bond C, double bond O, then H. So this is alpha, this is carbonyl carbon, and this carbon is alpha carbon, and this carbon is beta carbon. So beta carbon is having a hydroxy group, and the compound is an aldehyde, and 4 carbon atoms are there, so it is butyraldehyde. The name of this compound is beta hydroxy butyraldehyde. Okay, so this reaction is known as aldol condensation. Condensation means two molecules are being condensed. And why aldol? Ald comes from aldehyde, yet an aldehyde group is present, and all comes from alcohol group, because the molecule contains both aldehyde and alcohol. So this is a condensation between an aldehyde and an alcohol. So the reaction is known as aldol condensation or aldol reaction. Okay, so this is the reaction mechanism of Cannizaro reaction and aldol condensation.